In most modern homes, electricity is not perceived as a resource, it is perceived as a condition. Lights respond instantly. Refrigerators hum continuously. Climate systems regulate temperature with quiet precision. Internet routers transmit without interruption. The electrical layer of the household has become ambient, present, assumed, rarely examined. Unlike water, food, or fuel, electricity is rarely stored visibly within the home. It arrives through a network that extends far beyond property lines. Transmission towers, substations, regional grids, regulatory systems. The household does not generate it receives it. Over time, this arrangement has reshaped expectations. Appliances are designed with uninterrupted flow in mind. Work, communication, food storage, heating, cooling, all are structured around permanent availability. The dependency is not dramatic, it is procedural. And because it is procedural, it is often invisible. When this dependency becomes briefly visible, during storms, outages, or billing cycles, responses tend to follow familiar patterns. Some households purchase temporary backup generators. Others explore rooftop solar installations. Some attempt to reduce usage through behavioral adjustments, turning off lights, adjusting thermostats, staggering appliance use. Each of these responses addresses a surface layer of the dependency. They operate within the same structural framework. Electricity remains external, centralized, and regulated by broader systems. Even conservation efforts do not remove reliance. They merely adjust consumption inside the same grid architecture. The underlying arrangements remains unchanged. The modern grid is centralized by design. Power is generated at scale, transmitted across long distances, and distributed outward. This architecture optimizes efficiency and coordination, but it also consolidates control and vulnerability. A household cannot meaningfully influence generation capacity. It cannot stabilize regional transmission. It cannot negotiate rate structures beyond choosing among available plans. Dependency is embedded not just in wiring, but in infrastructure logic. Additionally, most homes are built with a single supply pathway. Electrical panels assume external input. Internal systems are not structured for autonomous operation. This creates a condition where comfort, storage, communication, and climate are all contingent upon uninterrupted external continuity. The dependency is technical, economic, and architectural at the same time. Historically, not all energy systems have operated exclusively through centralized grids. Mechanical storage systems, localized generation experiments, and hybrid infrastructure models have existed in various forms. Some relied on kinetic principles, others on small-scale mechanical accumulation of energy. In recent years, research institutions have revisited certain forms of distributed and stored energy concepts for specialized applications, including aerospace and remote operations. These formats differ structurally from conventional grid reliance. They shift emphasis from transmission to localized retention or mechanical conversion. However, they also introduce new engineering constraints, material requirements, and operational considerations. The existence of alternative formats does not eliminate dependency, it reconfigures it. Within this broader discussion, digital blueprint-based systems have emerged that claim to reinterpret older mechanical concepts for residential application. One example is a downloadable blueprint program that outlines the construction of a small-scale mechanical energy device intended for home integration. It is positioned not as a grid replacement in regulatory terms, but as an independent structural experiment in localized energy generation. Such offerings typically provide diagrams, material lists, and assembly documentation, rather than physical hardware. Their presence reflects a broader pattern. When centralized dependency becomes more visible, parallel informational ecosystems develop around alternative configurations. Whether these configurations meet engineering, regulatory, or practical thresholds depends on variables that extend beyond documentation alone. The modern household operates inside a deeply layered energy system. Its reliability has shaped behavior, architecture, economics, and expectation. Its invisibility has shaped perception. Dependency, in this context, is not a dramatic condition, it is a normalized one. When power flows uninterrupted, the system remains unnoticed. When it pauses, the structure becomes briefly visible. The question is not whether dependency exists, it is how deeply it is embedded and how often it is examined. The wires and the walls are visible. The structure behind them rarely is.